Hello guys, this is case B of type 4 constraint motion problems, and in these kind of problems the constraint factor is rho. So I'll be demonstrating this by an example that there are two blocks which are connected by a rope, and if we see that only this block is pushed, the left block is pushed towards right, then rope will become slack. Rope will become slack and there will be no tension in the rope. And in a slacked rope, any point can move independently, and the velocities of the different points can be different in a slacked rope. But if the right block is being pulled with some constant velocity v, then we can see that both the blocks will move together with that same velocity, and rope will be taunted and rope will have some tension. So this is also due to the fact that rope is not elastic in nature, and rope cannot be stretched beyond its taunted length, and hence I can say that the velocity of this point A and this point B will be same if rope has some tension and rope is taunted. So this is the concept which we will use in these kind of questions, and in this concept it states that when two objects are connected to each other with a stretched rope, then I'll make it then when two objects are connected to each other with a stretched rope, then the component of their velocity along the rope will be same, as rope cannot be elongated, which means that if this rope is not getting elongated and there are two blocks as shown in the figure, and one block is connected with the rope, and this other end of the rope is connected with other block which is restricted between two fixed rigid surfaces. And if this block will move forward, if this block will move downward, this will move forward, and therefore this angle will be variable and it will be different at all the instant of time. But we have to find out the velocity of this block v at the instant when this angle is 30 degree. So what do we do? So in this problem we can first we have to write the directions of the blocks which are moving. So we have already shown the directions of the blocks, and now we have to resolve the velocity of the blocks along the rope. So the component of velocity of this block along the rope will be v cos 30, and the component of the velocity of this block along the rope will be 10 only. So this point is moving with 10 meters per second downwards, and as the rope is not elastic, so this point will also be moving upwards with 10, and obviously this point is also moving upward with v cos 30. So we can say that v cos 30 will be equal to 10, and cos 30 is root 3 by 2, so v will be equal to 20 by root 3 meters per second. This is the velocity which we are calculating by this problem. So this is the concept. Now we move on. Next question. In this problem, the velocities of the bead. This is a bead. This is a bead, and bead, you can understand the bead from a ring which is sliding on this rod. Okay, so ring is restricted to move only along the rod, and ring can move only in x-axis, while this block is moving in y-axis only, because it does not have any horizontal force acting on it. So as this block will move downwards, then this ring will move forward and this angle will be variable. But we have to find out the velocity of this block at the instant of time when this angle is 45 degree. So we are applying our concept here, that we have to resolve the velocities along the rope. So the component of velocity of this bead along the rope will be 10 cos 45 degree, and the component of velocity of this block along the rope will be v itself. So I have to equate these two, that 10 cos 45 degree will be equal to v, and v will be equal to 5 root 2. Okay, so this is the required answer. Now let's move on in the next question. Now in this question you can see that this block A is moving downwards with a speed of 10 meters per second. This is C, which is moving upward with a speed of v, and this is B. It is also moving downward with a speed of 10 meters per second. Now we have to find out the velocity of C, with which it is moving in upward direction at an instant when this theta is 30 degree. So this theta is variable, but at this instant of time it is 30 degree, and at the same instant we have to find out the velocity of block C. So we are applying our concept that we have to resolve the velocity of block C along the ropes. So if this velocity is like that, this velocity is like that, it is v. So if I resolve it along this, so it is v cos theta, and I can say that the velocity of this point of the rope along the rope will be v cos theta, and the velocity of this point along the rope will be 10, and they will be equal. So I am equating v cos theta with 10, and v cos 30 will be equal to 10, and v will be equal to 20 upon root 3. This is the required answer. Okay, I hope you are getting it clearly, as this is a very simple concept which we can use in constraint motion problems of ropes. Now moving on, the next question. You can see that in this problem the velocity of this block is given as 10 meters per second, and we have to find out the velocity v of this block at an instant of time when this theta is 30 degree. So we are applying our concept that we are resolving the velocities along the rope, and in doing that you can see this is 10, and the component will be 10 cos 30 degree. Theta is 30, this is 30 degree, and this angle will be 60 degree. So this is 60 degree. So the component of this v along the rope will be v cos 60 degree. So 10 cos 30 degree will be equal to v cos 60 degree, and this 10 cos 30 is root 3 by 2, and cos 60 is 1 by 2. Okay, so we can see that v will be equal to 10 root 3. This is the correct answer. Now we move on the next question. Now in this problem, you can see that this ball is moving downwards with a velocity of 10 meters per second, and this ball is moving in right side with velocity v1, and theta 1 is equal to 30 degree and theta 2 is equal to 60 degree at this instant of time. And at the same instant we have to find out the v1 and v2, and v2 is the velocity of this ball in upward direction. So we can see that if this is v2, this is v1, and if I resolve this v1 along this rope, I'll get v1 cos theta 2. Okay, now v1 cos theta 2 is equal to 10. In fact, we have to resolve this 10 also. 10 is like that in downward direction, and if I have to resolve it along the rope, then if this angle is 30, this is theta 2 is 60, this angle is 30 and this angle is 60. So I can say that this angle is also 30 degree. So if I resolve this velocity 10 along the rope, it will be 10 cos 30. Now I have to equate v1 cos theta 2 and 10 cos 30. So v1 cos theta 2 is 60 degree, cos 60 is equal to 10 cos 30. So v1 will be equal to 10 root 3. This is the value of v1. Now this is v1. Now we are concerned about the next to find out v2. So to find out v2, we can see that v2 is like that. This is v2. This is v2 and this angle is 30 degree. So this angle will be 60 degree and the component of v2 along the rope will be v2 cos 60 degree. And if I extend the rope, then it will be like this, and this angle will be 30 degree. So the component of v1 along the rope will be v1 cos 30 degree. So v2 cos 60 degree will be equal to v1 cos 30 degree. Now v2 by 2 will be equal to v1. v1 is 10 root 3 and cos 30 is root 3 by 2. So v2 will be equal to 30 meters per second. Okay, this is the required value of v1 and v2. Now we move forward on the next question. In this problem, we can see that this ball is moving with 10 meters per second. This ball is moving with v1, and at the instant when this theta is 60 degree, this ball is also moving with v2 along the rope. Now we can see that the component of velocities of this ball, this one and this one along this rope is already given. Its velocity is v1 and its velocity is 10. So we can say that v1 will be equal to 10. Okay, now we have to find out v2, and the component of velocity of this ball along this rope is already v2. Now we have to resolve the component of v1 along the rope, and this angle is 60 degree. and this is V1. So the component of V1 will be V1 cos 60 degree. So I can say that V2 is equal to V1 cos 60 degree, and V2 will be equal to 5, as V1 is 10 and cos 60 is half. This was a very simple problem of type B, and now we move forward on next question. In this question, a block is dragged. This block is dragged on the smooth plane with the help of a rope, and rope is being pulled with a constant velocity v. So we have to find out the horizontal velocity of block. It is given that this block is being dragged horizontally on the smooth floor, and we have to find out this velocity of block along the floor at the instant of time when angle is theta. So we are using our basic concept that this angle is 90 minus theta, and the component of velocity along the rope of the block will be v sine theta, v block. So v block sine theta will be equal to v, and v block will be equal to v upon sine theta. Okay, so in this question we are again using this concept that when this block is being pulled by this rope, then the components of velocities of block and the rope along the rope will be same. Now we move on the next question. In this question, there are two blocks A and B which are moving as shown in the figure with velocities v1 and v2 respectively. Now they are connected by a rope which is going from a pulley, and pulley is fixed pulley, and we have to find out the ratio v1 and v2. So first of all, we have to resolve the components of v1 and v2 along the rope. So the component of v1 will be v1 cos theta 1, and the component of v2 will be v2 cos theta 2. So v1 cos theta 1 will be equal to v2 cos theta 2, and hence v1 upon v2 will be equal to cos theta 2 upon cos theta 1, which is the correct answer. Now we move on the next question.